Welcome, good people, to 8.3 Geometric Sequences and Series. Hopefully you're up to pace on the arithmetic sequences and series, because there's some most definite similarities between those, including the formula for the nth term of both an arithmetic and geometric, some true similarities. So anyway, we're going to go ahead and get started, but we're going to introduce this by showing an example of a geometric sequence. A geometric sequence could be, for instance, 3, 6, 12, 24, 48, 96, ... And I think it's pretty clear. We multiply by 2, etc. And 2 is said to be the ratio is 2. And a way to find the ratio when it's not so obvious would be to take this term and divide by 3. Or take 12 divided by 6, take 24 divided by 12. So that's where we come up with our common ratio on the sequences. The second, and we're going to talk about this nth term, but we're going to build it so you shouldn't have to memorize this whatsoever. And then these, the sum formulas, these might not be ones that will make sense to us. We're going to need to just know those for the time being. And that's going to be on part 2 of our video. So I'm going to just jump right into it with number 8. And number 8, determine whether or not the sequence is geometric. And this one pretty clearly, we need to say, well, we multiply by 4. We multiply by 4. And let's see if that continues. 48 times 4 is 192. We multiply by 4. Therefore, this is geometric, and the common ratio is 4. But number 12, not quite as obvious. Number 12, to find the proposed ratio, we would take the second term, -6, and divide that by 9. And that looks like a fraction that we'd be used to working with, -2/3. Let's see. Then I would take 4, divide it by the -6, same thing, and then we would take -8 on 3, divide that by the 4. And we get the same thing. Therefore, this is geometric, and the common ratio is 0.6 repeating, but probably preferred would be 2/3. And likewise, number 16, we could take go ahead and take the 2/7 and divide by, let's clear this out. I'm going to take the 2/7, I'm just going to put it in parentheses. 2/7, and we're going to divide by the 1/5. And then I'm going to take the 3/9. I'm going to put that in parentheses too. 3/9 and divide by the 2/7. And we see that we don't get the same results. Therefore, this is not geometric. Okay? Pretty straightforward, I believe. Let's take a look at 17 through 24. They want us to write the first 5 terms of the geometric sequence. This is, I think, so straightforward at this point that we can just list them. We start with 4, and every step we multiply by 2. So we get 4, 8, 16, 32, 64. For 24, we start with 7. We multiply by square root of 5. Oops, so I get 7 times square root of 5. And then we multiply by square root of 5 again. And if I multiply by square root of 5, square root of 5 times square root of 5, 5 times 7, 35. 35 times square root of 5. And one more time here, we'd end up with 35 times square root of 5 times square root of 5, 5, or 175. Pretty easy compared to some material we've been covering in this class. All right. Write the first 5 terms of the geometric sequence. So here we have what we referred to in the last section, actually 2 sections ago, as a recursive definition. Hopefully by now we're good at reading these. We say, hey, if I know a term, then all I need to do to get to the next term is multiply it by 1/3. So my first term, 81, my second term, 81 times 1/3. My third term, 27 times 1/3. 9 times 1/3 and 3 times 1/3. It says find the common ratio. Well, the ratio is 1/3. And then write the nth term. So to get to the nth term, and the formula's on the front page, but this is one that should make sense. To get to the nth term, we have to start somewhere. Why not at A1? Then we multiply by 1/3 and multiply by 1/3, multiply by 1/3, multiply by 1/3. Repeated multiplication implies an exponent. How many times do I need to multiply by 1/3? Well, to get from the first term to the 5th term, we multiply by 1/3 4 times. So to get from the first term to the nth term, our exponent needs to be 1 less than n. That's the number of steps of multiplying by 1/3. Common mistake some people will make now, they'll say, well, this is convenient, 81 times 1/3, and they'll say, well, 81 times 1/3 is 27 to the n minus 1. We can't do that. We really should think of this. You don't have to draw these brackets in there, but we really should think of it that way. Please excuse my dear Aunt Sally, we need to do exponents before we ever handle that multiplication. All right, we'll talk more about that in the second part of this, in one of the sum formulas. That happens a lot. So once again, hopefully we're good at reading this. If I know a term, I can multiply by -2/3 and get the next term. So first term 30. I'm actually going to make it 30 on 1, just because we're going to be multiplying by fractions here. Times -2/3. Positive times negative, negative. The 3 reduces the 30 to 10 times 2, 20 on 1. Times -2/3, negative times negative, positive. 20 times 2, 40. 3 times 1, 3. Positive times negative, negative. 40 times 2, 80. 3 times 3, 9. And negative times negative, positive. 2 times 80, 160. 3 times 9, 27. Our common ratio is clearly -2/3 each time. In fact, we know that before we list them out, hopefully. And then the nth term would be, we start with the first term, 30, and we start multiplying by -2/3, and we do that n minus 1 times, because that is the number of steps to the nth term, just like 4 is the number of steps to the 5th term. Okay, we're actually going to go with part B on here. We're going to do this algebraically. We're going to find the indicated term. So to find the 8th term, we need the 8th term equals, start somewhere, the 24, the first term, times common ratio 2.6 to get to the 8th term, it's 7 steps of multiplying 2.6 from the first term. So we will just calculate that one now. We'll go 24 times 2.6 raised to the 7th. We don't really need those extraneous parentheses that I put here, because our calculator is smart enough to know, please excuse my dear Aunt Sally, it will do the exponent first before multiplying the 24n. And we get 19,276.344, approximately 3 decimal places as always, unless specified. And the 11th term of this sequence. Well, the 11th term, A11, equals our first term 2 times square root of 3 repeatedly. How many steps to get from first term to 11th? 10. So we could just go on our calculator here. We'll do that. We'll go 2 square root 2 times square root of 3, and I'm going to raise that second factor to the 10th. And at first glance, it might seem a little bit surprising that we end up with 486 when we're not in no decimals, but this is equivalent to 3 to the 1/2 to the 10th, which is 2 times 3 to the 5th. Oh, that's why we end up with an integer value. All right, just a few more here because we are going to split this one into 2 sections. This is a one-day lesson for us following a quiz, so we were short on time. Find a formula for the nth term of the geometric sequence. Okay, well, and then we're supposed to find it for the indicated term. We could probably go to the indicated term immediately, but we'll do this. The nth term equals, we start at 3, let's see, that's times 12, and they're telling me it's geometric, but just for the sake of it, is 36 times, that's not 36. 36 times 12 does in fact get us to 432. So we start multiplying by 12s n minus 1 times. We just want the 7th term. 3 times 12 to the 7 minus 1 to the 6th. 3 times 12 raised to the 6 is pretty big. 8,957,952. Now, just to show you what happens, doesn't seem like a big deal, but if I just multiply that 3 in here first to the 12, I get 36 raised to the 6th. Not even close. So, pretty damaging to do that. 22nd term, times 2, ratio is 2, so real clearly the nth term. We start with 4, we start multiplying by 2's. How many times? Well, how many steps are we going? N minus 1 to get to the nth term. So we want A22. 4 times 2 to the 21st. It's going to be big again. 4 times 2 to the 21st. And once again in the 8 millions. 8,388,608. All right, 44. Here's where we have to trust our algebra. You're going to see what I'm talking about there. We've got a first term, we've got a third term. Find the indicated term. To get to the 8th term, I need to know what the ratio is. So, at one point, we made it to the third term. We started with 5. We multiplied by our ratio. How many steps to get from the first to the third term? 2 steps. So we get r squared equals, divide by 5, 9/4, and really tempting to say r equals 3/2, but that's the plus or minus square root of, and it matters. It might be a little bit of a surprise to you that that matters, but I want to show you this. Here is a real simple geometric sequence. 2, 4, 8, 16, 32. Here is another one. 2, -4, 8, -16, 32. Ratio 2, ratio -2. Our ratio is plus or minus 2 in those problems. So we can have a plus or minus ratio. From the first to the third term, maybe I stay positive, but maybe it goes positive, negative, back to positive. So, to find the 8th term, follow this. A8 equals, we start at 5. We start multiplying by either plus or minus 3 on 2. How many times do we do that to the 7th? Now, a positive to any power is a positive. This is 3. A positive to any power is positive, but negative switches. Negative to the 7th, the negative survives. Negative to the 7th is going to end up being a negative. So we're going to get 2 solutions to this. If this was to the 8th, I could just ignore the negative. It's going away, but it's not. So let's see. 5 times, I think I will enter this one as a fraction. I'm just going to go with the positive version. 3 halves raised to 7th, and I get, sorry about that, 5 3 halves raised to the 7th, I get 10,935 on 128, but that is plus or minus that. Plus or minus on that. You have to trust your algebra. I know all of my odd terms are going to be positive, but my even ones could be positive or negative. Each term could be positive or negative. Okay, let's go from here. Now they don't give us the first term. That's not an inconvenience at all. To get from the 2nd to the 5th, we ended up at 64 on 27. We started as -8. We multiplied that by some common ratio. How many times did we multiply it by that ratio from the 2nd to the 5th term? How many steps from 2 to 5? 3. So r to the 3rd divide -8 gives us -8 on 27. The 3rd root of that is not a problem. We can take 3rd roots of negatives. R is equal to -2 on 3. So here we have a negative ratio, which truthfully we should know that right from the beginning here. We're switching from negatives to positives. So we could do this. We could find the first term, multiply by -3 halves and move backwards, and then use the first term to find the 5th. Or we could do this. We could say the 5th term equals the 2nd term, careful, the 2nd term times -2/3 to the, how many steps from the 2nd to the 5th? Oh, excuse me, the 6th term. We could say the 6th term, because that's what we're looking for. We already did this. How many steps from the 2nd to the 6th? 4. We could do that. But we've got the 5th term, and we're only one term away. So I'm just going to say our solution is 64/27 times -2/3. 5th term, multiply by -2/3, get the 6th. -128 on 81. So the beginning of your assignment, I'll show you that, but we've got a little bit of work left to do on this section, is here. You should be equipped at this time to handle problems up through number 45. We'll come back on the next video and talk about some of these sums of geometric sequence problems. So good luck. Let me know if I can help you with anything. Stay tuned for part 2.